Now moving for the definition part. Now we are having, let f be a function defined on an interval I. I is what? I is an interval. I have just told only interval. It can be open, it can be closed. We are going to check it. Okay. Then what we are having now? Let f be a function defined on an interval I. Then now number one. Then number one, what is f is said to have f is said to have a maximum and what I told you in the introduction part, this can be also called as relative maximum value in I if there exists a point, if there exists a point. Now let a point be any point when we are going to draw a graph, a point in between the given intervals. Okay, if there exists a point, let the point be x0. Okay, such that now what is the condition for the point? Such that fx0 is greater than is equal to fx for all x belongs to I. This is the condition, such that fx0 is greater than is equal to fx. Okay, so this thing we are going to draw with help of a graph and an equation part. Okay. Now what we are getting from this thing? The number fx0 is called the maximum or relative maximum. Relative maximum value of f in I and the point x0. Now remember, there is a difference between fx0 and x0. So the number fx0 is called the maximum or a relative maximum value of f in I, and the point x0 is called point of maximum value in I. Okay. Now suppose I am going to give you an example. Suppose we are having a question fx and that is in the form of an cubic expression. We differentiate that equation and then we solved it for the critical points. Suppose we got one point, that is 2. Now when we are putting that particular point in the original question, that becomes f2. Suppose it is 2. So f2 when it is put in the original question, and then we are getting the maximum value. So putting f2 is called the maximum value, and the maximum value is on the point 2, that is called x0. Okay, so this is basically the fada. Okay, so now this was for maximum or called relative maximum. Now let's go for the minimum. Now f is said to have a minimum. A minimum, now it is called relative minimum. Relative minimum value in I if there exists a point, if there exists a point, if there exists a point x0 such that, now what we are getting, now what we are having here, such that fx0 is less than is equal to fx for all values of x where x belongs to I. Okay, for the relative maxima we are having fx0 is greater than is equal to fx. For the relative minima we are having fx0 is less than is equal to fx. Okay. Now the number fx0 is called the minimum, is called the minimum or relative minimum. Value in the number fx0 is called the minimum or relative minimum value of f in I, and the point x0 and the point x0 is called the point of minimum value. Or we can edit relative minimum value, okay, in I. So we are having one point, then we have second point, now we are having the third point, okay. Now going for the third one. Now what third point say? F is said to be, F is said to have an extreme value in I, extreme value in I if there exists a point x0 in I such that f x0 is. Now what happened? In the top side we were having a maximum point, in the second one we were having the minimum point. Now here we are having the extreme value, neither maxima nor minima, okay. F is said to have an extreme value in I if there exists a point x0 in I such that fx0 is either relative maxima value of f in I. So for this particular parts, for relative maxima, we can only use this maximum term also. Okay, so this is the definition part. Now we have gone through. After the definition, now I will just be giving you some nice examples and then a graphical part also. Okay, so we have to go for this function with the help of these definitions.